Okay, so when you're deep in an NS3 simulation, you're swimming in data, right? We're talking packet transmissions, delays, routing, the whole shebang. But usually it's all just text, stuck in a log file. So today, we're going to talk about how to take all that abstract stuff and turn it into a clear, visual story.
I mean, really think about that for a second. What if instead of just scrolling through endless lines of logs, you could actually watch your code in action? See the nodes pop up, see the connections form, and watch the packets zip back and forth. That, right there, is the power of network visualization. And trust me, it's a total game changer. So yeah, let's dive right in.
So here's the plan. We'll start with the why this is so important. Then we'll meet our star tool, NetAnim. From there, we'll get into the code itself, flip the switch to enable animation, and then, of course, check out the final picture.
All right, first up, from data to vision. The biggest problem with any simulation is that it's invisible. The engine is doing all this incredibly complex work under the hood, but we can't see any of it. It's kind of like trying to figure out what's happening in a play just by reading the script without ever seeing the stage.
And this slide just nails the difference. On one side, you've got your standard simulation logs. They're dense, they're abstract, and let's be honest, debugging with them can be a total nightmare. But on the other side, a visualization. It's intuitive, it's clear, and it reveals things almost instantly. And this isn't just about saving a little time. We're talking about the difference between spending hours hunting down a bug in a text file versus just seeing it like, oh, there it is, that packet's going to the wrong node in seconds.
So why do we even bother with this? Well, look at this list. These aren't just little perks, they're absolutely fundamental. Visualization lets you actually see the network's layout, watch how things are talking to each other, and spot a bad config from a mile away. But the biggest one for me is the last point, building intuition. It helps you develop that gut feeling for how all these abstract concepts really work in practice, and that is what takes you from just knowing the theory to actually understanding the network. It's about seeing the problem before you even have to dig into the raw data.
So how do we pull this off? How do we get this visual insight? Simple. We use a tool that's basically a camera for our simulation, and that tool is NetAnim. So what exactly is NetAnim? It's the official animator for NS3, and its job is actually pretty straightforward but really powerful. As your simulation runs, NS3 creates this special XML file that's like a log of every important thing that happens. Then, when the simulation is over, you just pop that file into NetAnim and it plays everything back for you like a movie.
A few key things to remember about NetAnim. First, it's an offline tool. That means you run your simulation, then you watch the replay. It's not happening live. It can handle both wired and wireless networks, showing you all the nodes, the links, the packets flying around. And, this is super important, it's only a visual tool. It doesn't mess with your simulation's results at all. It's just a window into what already happened.
Okay, time to get our hands dirty. Before we can have a cool visualization, we need something to visualize, right? So we need a simulation. Let's think of this part as writing the script for our little network movie.
And we're going to start with something really, really simple. The goal is just a basic network with two nodes. One's going to be a client, and the other's going to be a server. Specifically, a UDP echo server, which is just a fancy way of saying it acts like a parrot, it listens for a message, and sends the exact same one right back.
All right, step one. Just like any coding project, we've got to bring in our tools first. In NS3, we call these modules, and we just include them right at the top of our C++ code.
So you'll see a few includes here. One for the core simulator, for networking, for applications, but check out that last one, netanimodule.h. That's the one we care about today. That little line is what gives us all the special commands we need to make the animation file. It's the magic ingredient.
Okay, tools are ready. Now for step 2. We need to cast our actors. And in our network movie, the actors are the nodes. The virtual computers or devices that are going to do all the talking.
And would you look at how simple this is? We make something called a node container, which is basically just a handy way to keep track of our nodes. And then we just tell it, hey, create 2. And boom, that's it. We have 2 virtual computers ready and waiting.
So our actors are on stage, but they can't just stand there in silence. They need a way to talk to each other. Step 3 is all about connecting them with a communication channel. We're just going to use a basic point-to-point link. And what's cool is we can define exactly what that link is like. So for our script, we're setting the data rate to 5 megabits per second. That's how fast data can move. And a delay of 2 milliseconds, which is how long it takes a signal to get from one end to the other. This is what starts to make our simulation feel a bit more real.
Okay, step 4. We have our actors, we have the stage, now we need to give them their lines, their roles to play. And we do that by installing applications on them. We'll tell one node, you're the server, and the other, you're the client.
So here's how we set it up. The server application goes on node 1, and we tell it to wake up at the 1 second mark. Then the client application goes on node 0, and we tell it to start at the 2 second mark. Now why the delay? It's all part of this core idea called discrete event simulation. You have to schedule things in order. You need to make sure the server is ready and listening before the client tries to make the call, right? You can't call someone before they've even picked up the phone. And now, we've arrived at the most important part of this whole thing. We've written the script for our network play, but we haven't yelled action yet. We haven't told the camera crew to start rolling. These next few bits of code are like the director's notes that actually bring it all to life.
Seriously, everything we've looked at up to this point is pretty standard NS3 setup stuff. But the line of code coming up next, that's the magic switch. That's the secret sauce that tells NS3 to start recording for our animation.
And here it is. This single line does basically all the work. We create an animation interface object, and we just give it a name for our output file. As soon as NS3 sees this line, it knows to start logging every important event, every new node, every packet sent into that XML file. That's it.
Okay, there's one last little thing we should do to make our animation look good. It's like blocking in a play. If we don't tell our actors where to stand, they'll just show up in random spots on the stage. For a nice, clean picture, we need to give them specific positions.
So we use this handy function, setConstantPosition, to nail down exactly where each node goes. Here you can see we're putting our first node at the coordinates 0, 5, and the second one over at 10, 5. It's a really simple step, but it's so important because it means our network layout will be clean and predictable every single time we watch the animation. No surprises. All right, we've done it. The script is written, the actors have their positions, the director has given the notes. It's time to run the simulation and screen the final cut.
And the actual workflow here could not be simpler. First, you run your simulation script. That automatically creates the XML file we talked about. Then you just fire up NetAnim, open that file, and that's it. You're watching your network come to life.
So what are you actually going to see on the screen? You'll see our two nodes sitting exactly where we told them to be. Then, right at the 2 second mark in the simulation timeline, you'll see a packet shoot out from the client, travel across the link to the server, and then, a moment later, the server will send one right back. You're literally seeing your code work. You can watch the simulation clock and see the events happen exactly when we scheduled them. It's the perfect way to confirm everything is working.
Look, by taking abstract code and turning it into something you can see and interact with, visualization makes NS3 just an incredibly powerful tool for learning, for debugging, for everything. It gives you the power to not just get an answer, but to actually understand how you got it. This isn't just about making pretty animations. It's about becoming a better, more insightful network engineer. So the only question left is, now that you can see your network, what are you going to build next?